Hi, this is Ms. Schultz. So we're doing this lesson on implicit differentiation. It's a specific application of the chain rule. Okay, so let's consider this. See how y is alone and by itself and isolated? And then the x's are all on the other side. So here we say x is explicitly a function of x. So this is very clear that y is explicitly defined. Here, y is not isolated and cannot be isolated, in fact. Like you can't solve for y. You can factor out a y, but then you would still have a y squared here. You can't isolate y. So here we say y is implicitly a function of f. And in fact, it might not even be a function at all. It could be a relation. So we have not, in your mathematical careers, dealt with equations that look like this very much. So that's why this section, we're teasing those out, and all of our equations will be implicitly defined, and we're going to take the derivatives of them, hence implicit differentiation. All right, let's go. Okay, so an application of the power rule combined with the chain rule. So if I want to take the derivative of both sides, I'm going to do h prime of x equals n times g of x to the n minus 1. But wait, I'm not done. What do I need to add to the end? Times g prime of x, because that's the chain rule. Okay? So instead of g of x, we know this is an output of a function, so I'm just going to call that y, all right? So I'm going to say h of x equals y to the n. So h prime of x would equal n times y to the n minus 1 times the derivative of the inside, which is the derivative of y is y prime or dy dx. I'm going to use this notation, dy dx. So why do I multiply by dy dx? Because that's the derivative of the inside. Now, if you have x on the inside, the derivative of x with respect to x is 1. So I didn't have to do this before because I would just, when I apply the chain rule, I would just be multiplying by 1. But here, every single time I take the derivative of y, I need to have the derivative of y represented. All right, let's see more about how this works. So I have this equation. It's the equation of a circle, radius at the origin, radius of 6, center at the origin. All right, so if x squared plus y squared equals 36, find dy dx. Let's go piece by piece. What is the derivative of x squared? 2x. All right, we know that. Now, even if we had known that, if I want to think about it, the chain rule, if I want to think x squared and take the derivative of this, okay, I think 2x to the first times the derivative of x. What is the derivative of x? And I'm taking the derivative with respect to x, so the derivative of x is dx, that stands for derivative of x, with respect to my independent variable, which is dx. So this would be 2x times 1, or just 2x. All right, now on this side, when I took the derivative of y, I'm still taking it with respect to x. X is still my independent variable. So I'm going to think of this as my inside. So this would be 2y to the first times, see how my inside is staying the same, times the derivative of the inside. What's the derivative of y? It's dy. And what's my independent variable? So that's with respect to dx. See how here dx, so that makes 1, that divides to 1, and here this doesn't cancel out. So that's the main difference of why this doesn't have anything afterwards being multiplied, and this does. Because this, the thing it's being multiplied, is a form of 1. But this just simply doesn't cancel out. Now what's the derivative of 36? It's 0. So the derivative of the whole thing, okay, the derivative of 2x, x squared is 2x, plus the derivative of y squared is 2y. I don't need to put in the parentheses, dy dx equals 36, 0. So one common mistake is you start with an equation, and people will forget this part. So if you start with an equation, be sure to end with an equation. Don't accidentally make it an expression and do that. You know what I mean? Okay, so that's the derivative. If I want to find, I'm going to isolate dy dx though. So what should I do first to isolate dy dx? Subtract 2x, subtract 2x, 2y dy dx equals negative 2x. Now I'm going to divide by 2y on both sides. So dy dx equals, the 2's can cancel, so negative x over y. So that is my derivative solved for. This is the derivative. It's just not like the derivative is isolated. So I'm isolating here my dy dx. And that's what I want you to do every time. I have steps that list later. Okay. All right, let's make sense of this. So we knew that dy dx equals negative x over y. See? Yep. All right, so let's just see this. Find the slope when x equals 2. So dy dx equals negative 2 over, it doesn't tell me the y. How could I find the y here? I always thought, if I ever want to find a y, I substitute into the original. So 4 plus y squared, that's 2 squared, plus y squared equals 36. So y equals plus or minus the square root of 32, which is like 5 point something, right? 5 point, I don't know, 8, plus and minus. So I actually have, so I have 2. I have over 5.8, and I have negative 2 over negative 5.8. So I have, okay. So this would be 2 comma root 32 and 2 comma negative root 32. If you want to know why there's like 2 points, it's a circle. Yes, it's a circle with radius of 600 at the origin. This is where 2 hits the circle, and it hits it at 2 spots. Those 2 spots. So a lot of implicitly defined functions aren't, relations aren't functions. Okay, so let's say this is about negative 2/3. About negative 2/3, and this is about positive 2/3. Okay, so at positive 5.8, it's here. Would you say the slope is around negative 2/3? Yep. And here at, when I plug in negative 5.8, I'm at this point. This is 2 comma negative 5.8. And would you say my slope is about 2/3? Yes. Okay. So that's like a visual of seeing how my derivative works. All right, let's do this next one. Just another example, okay? So I'm going to put this in parentheses so I can see my chain rule. So this would be 6x squared. And then I'm not going to put this, don't write this down, but like this would be times the derivative of the inside would be dx dx. But see how that's 1, so I don't need to do that. So when I take the derivative of x, it's the same as always. Okay? Now I'm going to take the derivative of y. So this would be minus 6y to the first times the derivative of the inside. I do need to do this for, okay? Don't stop here, it's an equation, so I must keep it an equation. The derivative of 7 is 0. A lot of people make the mistake of just putting a 7 here. The derivative is 0. So now let's solve for dy dx. So I'm dividing by negative 6 on both sides. They cancel, so this would be x squared over y. All right, let's keep going. All right, let's do this one. So I have this function here. Okay, 3x squared plus xy squared equals 16x. What's the derivative of 3x squared? Nothing's changed. 6x to the first. Okay. xy squared. Woo. You have to use the product rule. Alert. Product rule. You have to use the product rule for this one. Why? Because there's 2 different variables being multiplied together. Okay? So I'm going to say my u is x, my v is y squared. du, dv, So what's the derivative of each one? Take a sec. Derivative of x is 1. Derivative of y squared is 2y to the first times the derivative of the inside. If it helps you to do that, you can do that. dy dx. Okay, so I did the derivative of 3x squared. I did the derivative of xy squared. And now equals, I'm going to take the derivative of 16x, which is right here, 16. Okay, so now I'm going to put it all together. This is my whole problem here. I'm going to find dy dx. So this guy, the derivative is 6x. The derivative of xy squared. Oh, I didn't really finish this up now that I think about it. Okay, so I forgot to crisscross here. So this would be, the derivative would be 2xy dy dx plus, product rule plus, y squared. That is the derivative of xy squared. So I'm going to go put that down here. So plus 2xy dy dx plus y squared. So like this derivative is all of this, because I have to use the product rule. Why do I have to use the product rule? Because this is multiple variables in the same term being multiplied together. Okay, now I'm going to do the equals sign. The derivative of 16x is 16. Okay. So now it's asking for me to find dy dx, so I'm just going to isolate that. So I'm going to group all my terms that don't have a dy dx to the other side. I'm going to say that again. All my terms that do not have a dy dx, I'm going to put it on the other side. So 2xy dy dx equals 16. I'd subtract this from both sides, and I'd subtract this from both sides. Now to isolate this guy, I'm going to divide. And I divide the whole, I divide this whole term, 6x minus y squared, over 2xy. All right, and I'm done with that problem. Okay, so the big takeaway here is to use the product rule in this situation. So we're going to use the product rule actually in most, I'll be honest, in most implicit differentiation problems, you have to use the product rule. And then every time you differentiate y, you're going to have to use the chain rule and do this times dy dx. That's how implicit differentiation is different. And then at the end, you have to solve for dy dx. All right, let's do this guy. This one's going to be a step harder. So let's go through and take our derivatives one by one. So the derivative of x squared, 2x. What is the derivative of this term? I'm going to think of it as plus a negative, okay? You could totally think of it as minus a positive, but I just have to pick one way to do it, and so that's how I'm going to do it. So let me see if I can zoom in a little bit. Yeah. Okay, so this, I'm going to do some scratch work on this side. This necessitates the product rule. Okay, so my u is negative x. My v is y. It's a v. My du is negative 1. What's the derivative of y? Simply dy dx. So why does y act so differently? It's because my independent variable is x. So the derivative of x with respect to x, those match, which means it's something over itself, which is 1. This is not my independent variable, so it doesn't match, so I need its derivative. Okay, now I'm going to crisscross. So I changed it to a plus, so I wouldn't have to worry about distributing anything. So plus, and I'm going to multiply this, negative x dy dx, plus, because that's the product rule is a plus, negative y. So like this is the derivative of that little bit, okay? So this one term, its derivative is 2 terms, because that's how the product rule works. Okay, what's the derivative of y squared? If it helps you, put that in parentheses to see that that's the inside. I'm going to have to use the chain rule. So 2y to the first times dy dx. 7, the derivative of 7 is 0. Okay, so now I'm going to isolate dy dx. What? What is up with this? Hold on. How do I isolate dy dx? Because, look at this. Dy dx is in 2 different places. How do I get it alone if it's in 2 different places? Well, I'm going to start by doing what I did here. So what I did here was I got the terms that didn't have a dy dx to the other side. That was where I started. So that first step, still the same, okay? So I'm going to subtract this from both sides and add this. Subtract 2x from both sides and add y to both sides. So I'll get negative x dy dx, s gone, plus 2y dy dx equals negative 2x plus y. Now maybe you can see it, but if I want just a dy dx equals, that's what I want, okay? I needed the dy dx to be in one place only one place. How can I get the dy dx in one place instead of in both terms? It's a common factor, so I will factor it out. Dy dx, parentheses, negative x plus 2y equals negative 2x plus y. And now I can isolate this by dividing. So this is similar now. See how I divided by 2xy on both sides? Like I divided by the coefficient of dy dx. So that's what I'm going to do here. So I'll do dy dx equals negative 2x plus y all over negative x plus 2y. And you can't simplify that. This is 1, 2, 3, 4 terms. All 4 terms would need to have a common factor to simplify it. Okay, so this is a summary of the steps we just did. This is as hard as it gets with the factoring out and using the product rule, right? Okay, so these are the steps. Differentiate both sides of the equation with respect to x. Collect all terms involving dy dx on the left side. That's what we did here, okay? And all other terms on the right side. Then factor out the dy dx, then divide to solve for dy dx. All right, you're gonna do APQ2 now, all right? So please pause the video and take a sec to do it, and then we'll check in. All right, this is how you do it. The derivative of y squared is 2y. I'm going to change this to plus and negative. This is a product rule. I'm going to do it on this side. Negative 2x and y. It's my u and my v. So my du is negative 2. My dv is dy dx. So plus. Okay, so the derivative of this term is going to be negative 2x dy dx plus negative 2y. Okay, so that's the derivative. Equals, not 16, but 0, because you take its derivative. So now I'm going to isolate dy dx. Cool, it's only in one place, so that means I'm not going to need to factor. Negative 2x dy dx equals negative 2. Wait, really? These cancel? No way, they cancel. So just 0. Did I do something wrong? Hold on. Negative 2y. Oh. Wow, I made a mistake. Okay. Wow, here, JK. The derivative of y squared, don't make that mistake, is 2y dy dx. So this is 2y dy dx. All right, so I'm just going to add this to both sides, equals positive 2y. So I do need to factor because I do have a dy dx in both places. If you start with a y in multiple places, you're going to end up with a dy dx in multiple places. Okay, so I collected my dy dx terms on the left, my other terms on the right. Now my next step is to factor If you want to divide everything by 2 here, by the way, you can. I guess I'll just do that later. dy dx times 2y minus 2x equals 2y. And then divide to isolate dy dx. dy dx equals 2y over 2y minus 2x, which is y over y minus x, which is C. All right. So I want you to do APQ4 here. All right. Let's see. I'll do it real quick, but you do it on your own and check in. Okay. So 2xy dy dx plus y squared. That's the derivative of the first product rule plus derivative of the second of 2xy is that plus 2y. That's the derivative of the second term equals 0. Okay, now at 1, 2, here's what I want you to do. I want you to substitute in a 1 for my x and a 2 for my y. I don't need to solve for this first. I do not need to solve for that first. I don't want to mix them up, so I'm gonna do that. Label them. dy dx plus y squared is 2 squared plus 2, 1 dy dx plus 2 times 2 equals 0. So it should be 4 dy dx plus 4 plus 2 dy dx plus 4 equals 0. So negative 8 on this side, and then 6 dy dx on that side. So dy dx is negative 8 over 6, or negative 4 over 3. Okay, so the point is, if you're substituting in a number, I highly recommend that you substitute in as soon as you can, all right, instead of dealing with the variables for longer. All right, this is me checking out. Bye, have a good one.